1 liter atmosphere is equal to 101.3 joules. Conclusions from first law of thermodynamics. Types of heat capacity, Mayer's formula. Cp minus Cv is equal to 2R for 2 moles. And degree of freedom you see here, monoatomic gas is equal to 3 into 1 is equal to 3. All the respective values given here, Cv is F by 2R, Cp is R plus Cv, gamma is Cp by Cv. Maximum values, 3 translational, 3 rotational, maximum. JEE Main 2026. 23rd January shift 1. One hidden number controls heat capacity, internal energy and even first law of thermodynamics. That number is degree of freedom. Let's master it in just few minutes. Hello students, let us start. Heat capacity and degree of freedom. First, if you see internal energy represented by E or U, it is the sum of all microscopic kinetic energies and microscopic potential energies of the particles present in a system. It includes total energy, translational energy, rotational energy, vibrational energy, electronic energy, chemical bond energy, nuclear energy, etc. Key points about internal energy: it is a state function. Delta U depends on temperature, represented by U or E. If delta T is 0, delta U is 0. Delta U it is, so change in internal energy. First law of thermodynamics, in short you can refer it as FLOT. Energy can neither be created nor destroyed. It can only be converted from one form to another. Or delta U, heat supplied to system plus work done on the system. Heat supplied to system plus work done on the system. For example, when 1 mole of gas expands from 1 liter to 5 liter against constant external pressure of 1 atm, find work done by the gas. So we know general formula W is minus P delta V. So minus 1, delta V is V2 minus V1. So overall we are getting minus 4 liter atmosphere. But we know 1 liter atmosphere is equal to 101.3 joules. Law of equipartition of energy. So overall it is equal to approximately minus 400 joules. Another question, gas occupies 2 liter at STP. It is provided by 300 joules of heat, so that volume becomes 2.5 liters at 1 atm. Find delta U in joules. How to solve such questions? See here. Q is plus 300 because heat given to system is positive. P is 1 atm given. Delta V V2 minus V1 2.5 minus 2 0.5 liters. W formula, that is minus P delta V. So if you substitute the values, minus 0.5 liter atmosphere. If you convert into joules, you will get 50 joules approximately. They are asking delta U in joules. So what we do that? Delta U is equal to Q plus W for first law of thermodynamics. 300 minus 50 will give 250 joules. Why it is minus 50 here? Because they mentioned C. So that volume becomes 2.5 liter to 1 atm. 2.5 liter to 1 atm. But anyway here question itself we got here minus 50 joules. That's why we substituted same value. Conclusions from first law of thermodynamics. Conclusions from first law of thermodynamics, FLOT. Isothermal process, we know temperature is constant. If temperature is constant, internal energy change is constant. According to first law of thermodynamics formula, if you substitute these values, Q is equal to minus W. These are important conclusions. Isobaric process, delta P is 0, so delta U is equal to Q plus W here. Isochoric process, if delta V is 0, delta V is change in volume is 0, W is minus P delta V, so then W should be equal to 0. According to first law of thermodynamics formula, if you substitute the values, delta U is equal to QV. What is delta U here? Delta U is change in internal energy. Here delta V it is change in volume. QV is heat measured at constant volume. So one important note here, Q is path function, we studied in previous video. See, basic terms of thermodynamics we studied in previous video. If you did not watch previous video. QV, state function, because delta U is equal to QV, delta U is state function, so QV behave like state function. Cyclic process, all state functions are 0 in cyclic process, that is delta U also 0. Delta U is 0, then Q is equal to minus W. Adiabatic process, if Q is 0, adiabatic process we know Q is 0, delta U should be Q plus W adiabatic, so delta U is W adiabatic. W is path function, we know depends on path, but W adiabatic work is equal to delta U, so hence it is behaving like state function. With delta U is state function which is equal to W adiabatic, hence you can refer it as state function. Types of heat capacity, that is C, Heat required to increase the temperature of a system by 1 degree Celsius. Heat capacity. C is plus Q by delta T. Units of C, joule per Kelvin or joule per degree Celsius. Molar heat capacity Cm. Name itself indicating heat capacity per mole of the substance is molar heat capacity. Cm is plus Q by N delta T. Per mole it is just extra N value we are adding, number of moles. N is number of moles. So units of Cm here, joule per Kelvin per mole. Joule per Kelvin per mole. Specific heat capacity, that is Cs. Specific heat capacity. Heat capacity per gram of the system. Heat capacity per gram of the system is specific heat capacity. Per mole it is molar heat capacity. Per gram it is specific heat capacity. Extra term W, mass of the substance we add in grams. There we added N, here it is W. Units of specific heat capacity, joule per gram per Kelvin. Heat capacity at constant volume Cv and constant pressure Cp. So if we calculating heat capacity at constant volume, heat should be at Qv. So Qv by delta T. At constant pressure, Qp by delta T. Here constant pressure. Molar heat capacity at constant pressure and volume. So here what we write? Cvm, Cpm. Here it is heat capacity at constant volume. Here it is molar heat capacity at constant volume. Heat capacity, here it is heat capacity at constant pressure, which is molar heat capacity at constant pressure. Okay, that's why we specified different formulas. Heat measured at constant volume is delta U, change in internal energy. Heat measured at constant pressure is delta H, change in enthalpy, delta H. We know that Qv is NCVM delta T. How? Here you see. Qv is NCVM delta T. If you bring this side, Qp is NCPM delta T. So Qv is NCVM delta T. In place of Qv, what you can write? Delta U you can write, because heat measured at constant volume is delta U. So in place of Qv you can write delta U, NCVM delta T, NCVM delta T. Qp also same, NCPM delta T, because heat measured at constant pressure is equal to NCPM delta T. Delta H is equal to Qp, so you will get this equation. Enthalpy H, heat measured at constant pressure is equal to change in enthalpy. Heat measured at constant pressure is equal to change in enthalpy. Okay, so delta H is equal to delta U plus P delta V. This you have to remember. Delta H is equal to NCP delta T. Delta H is equal to NCP delta T. Just now we studied here, NCP delta T. Okay, so for chemical reactions, external temperature and pressure constant if you consider, delta H is equal to delta U plus delta Ng RT. Only number of moles changing. For example, if you consider number of moles changing, delta Ng RT, where delta Ng is change in gaseous product moles minus change in gaseous reactant moles. For example, see, if this reaction given, delta Ng, how we calculate? Any gaseous product here? No gaseous product. Left hand side here, no need to consider. Only half. So 0 minus half minus 1 by 2 is delta Ng here. Okay. Now proceed for Mayer's formula. See, if any doubt in particular concept, pause the video, observe it. Mayer's formula, delta H is equal to delta U plus Nr delta T. Here temperature changing, constant temperature changing, delta U plus Nr delta T. If you divide equation by N delta T, divide equation by N delta T, so what you will get? See here. Here, if you divide by all, in place of delta H, what you can write? Qp. In place of delta U, Qv. So this we know. So if you write in place of delta U, Qv and Qp, after division, what you will get? Here you will get 1, because same values. So this particular value, you can write it as Cpm. Qp by N delta T is, so what we can specify here? Cpm minus Cvm is equal to R. How we are writing this particular part? You see once. Cpm is N Qp delta T. Here we wrote C. Cpm, if you bring this side, what you will get? Delta H by N delta T. So same we are writing here, Qp by N delta T, or you can say Cpm minus Cvm is equal to R. Okay. So Cp by Cv is Poisson's ratio gamma. Remember, Cpm minus Cvm R is equal to R. Cpm and Cvm are molar heat capacity. Cp and Cv are heat capacity per 1 mole. So if you are writing formula like this, Cp minus Cv is R, that is for 1 mole. Similarly, Cp minus Cv is equal to Nr, that is for n moles. Cp minus Cv is equal to 2R for 2 moles. It is only about heat capacity, not about molar heat capacity. Okay, and degree of freedom you see here. Degree of freedom, the total number of modes in which a molecule of an ideal gas can exchange during collisions. Total number of modes in which a molecule of an ideal gas can exchange energy, we can specify an exchange energy during collisions is known as its degree of freedom. Or in simple lines you can see number of ways in which a gas molecule can move. Number of ways in which a gas molecule can move in simple lines. Total degree of freedom is translational degree of freedom, rotational degree of freedom, vibrational degree of freedom. However, vibrational degree of freedom observed only at high temperature. So in chemistry, degree of freedom in detail not required. No questions asked about what is degree of freedom in detail. So here number only we need in chemistry. Physics you are going to discuss in detail. These three together will get total degree of freedom. However, vibrational degree of freedom observed only at high temperature. In question if they mention high temperature, then only we add vibrational degree of freedom. Here reference given, gas type and degree of freedom. Monoatomic gas where single atoms present. There 3 translational, 0 rotational, because single atom it is, no rotational motion considered here. 3 translational, 0 rotational, so overall it is 3 here. Diatomic or linear triatomic. Linear triatomic means CO2, diatomic like H2, Many examples you can consider the same category. 3 translational, 2 rotational, total 5 it is. Triatomic non-linear, SO2 if we consider, triatomic non-linear, so 3 translational, 3 rotational, overall you will get 6 here. 3 translational, 3 rotational, it is 6. So here remember it is whatever we consider here at low temperature. We did not include high temperature here. So at low temperature you can consider this particular part. Okay. And now you see here, note, total degree of freedom is translational, rotational, vibrational at high temperature. So here you can specify like this 3n. We can mention like this 3n. So n is atomicity here. N is atomicity. So 3n, that is n is atomicity here. So monoatomic gas is equal to 3 into 1 is equal to 3 atomic gas 3n. So 3 translational, 0 rotational, 0 vibrational. 3 translational, 0 rotational, 0 vibrational. So monoatomic gas, that is 3 into 1, that is 3. Translational, 0 rotational, 0 vibrational here. Remember. If it is diatomic gas, 3 into 2, 6. Atomicity is 2, right? Atomicity meaning number of atoms. 3n. So what you will get here? 3 translational, 2 rotational, 1 vibrational. Triatomic linear, 3 into 3, 9 here it is. So 3 translational, 2 rotational, 4 vibrational. Triatomic non-linear. So triatomic non-linear, 3 into 3, that is 9. So in this case overall 3 translational, 2 rotational, 4 vibrational. Triatomic non-linear, 3 into 3, 9 here it is. Overall you get 3 translational, 3 rotational. See, maximum translational rotational only 3 and 3 vibrational, whatever left over vibrational. Tetraatomic total 12. So 3 maximum translational rotation, remaining all vibrational degree of freedom. In JEE Advanced, high temperature required, otherwise normal low temperature only we consider. Next, law of equipartition of energy. According to this law of equipartition of energy, energy equal to 1 by 2 kT. Energy equal to 1 by 2 kT is associated with each degree of freedom per ideal gas molecule. With each degree of freedom per ideal gas molecule. Like internal energy per molecule is F 1 by 2 into kT. Internal energy per mole it is F into 1 by 2 into K into Na into T. So here K into Na we know, that is R, gas constant, K into Na, gas constant. So internal energy per n moles is equal to F into 1 by 2 into R into T into N. So K into Na is R into T into N. N is number of moles. Delta U is equal to NFR delta T by 2. So keep in mind here, this product of these two is equal to gas constant R. Overall delta U for n moles, NFR delta T by 2. Or how we can write F by 2 RT for 1 mole. And we know CV is change in internal energy at constant volume we know, du by dt at constant volume Cv, and differentiate above with respect to T, what you get? Cv value you get F by 2R. So Cv is F by 2R. F is total degree of freedom. F is 3 for monoatomic, 5 diatomic linear at triatomic, 6 triatomic non-linear for low temperature. Cp and Cv values also given. Gas, Cv, Cp, gamma. So all the respective values given here. Cv is F by 2R, Cp is R plus Cv, gamma is Cp by Cv. Respective values given here. And here remember always gamma values that is greater than 1. Contribution of total degree of freedom, rotational degree of freedom towards Cv is F by 2 each. Contribution of Fe towards Cv, Fe means vibrational degree of freedom is R. Only at high temperature we consider this. For example, see here, 10 moles of O2 is heated at constant volume from 30 degrees Celsius to 40 degrees Celsius. The delta U is dash calorie. Cp is 7 calorie per mole per Kelvin. R is equal to 2 calorie per mole per Kelvin. Cp minus Cv is R. So then overall, what you are getting? Cv value is 5 calorie per mole per Kelvin. Delta U should be NCV delta T. We know. So hence 10 into 5 into 10, that is 500 calories. Direct formula. Gamma for NH3 at low temperature, high temperature they asked. High temperature include Fe also, vibrational degree of freedom. Cv at low temperature, we know F by 2R. F is translational per rotational. 6R by 2, because which is, it is tetraatomic gas. Tetraatomic gas. Even tetraatomic gas, maximum what are the values? Tetraatomic or pentaatomic, whatever it is. Maximum values 3 translational, 3 rotational, maximum. So 6R by 2, 3R. Cp value Cv plus R, 4R. So Cp by Cv is gamma. So 4R by 3R, which is gamma, is 1.33. At high temperature, Cv is F by 2R plus FVR also you have to consider. What is FVR? Vibrational degree of freedom. Just now we studied contribution of translational rotational degree of freedom is 1 by 2R. Vibration it is R. 6R by 2 plus 6R it is, because in tetraatomic vibrational degree of freedom, that is 6 modes, 6R is equal to 9R. Okay, it is 9R. So overall if you see here, Cp is 9R plus R, 10R. Cp is equal to 9R plus R, that is 10R you will get in this case. So it should be clear how we are getting 4 here. See, for tetraatomic, NH3 is tetraatomic. So then 3 into N, so which is 3 into 4, which is 12. Out of 12, 3 plus 3, translational, vibrational 6, plus remaining 6 vibrational. Translational, rotational. So remaining 6 we wrote it as vibrational here. Here 6R, that is 9R. Cp is equal to 9R plus R, that is 10R total. Cp by Cv is equal to 10R by 9R, which is 1.1 gamma value for the given question. Okay. And now you see JEE Mains 2026, 23rd January shift 1. A cup of water at 5 degrees Celsius system is placed in a microwave oven, and the oven is turned on for 1 minute, during which the water begins to boil. Which of the following option is true? So here what happens? 5 degrees Celsius, for 1 minute if you use microwave oven, it goes to very high temperature. Very high temperature it goes under 1 minute microwave oven. So change in heat is very high. Change in difference in, that is heat energy, it dominates. First of all, the heat given to the system is your food. For example, think that system is given food it is. So cup of water they mentioned, system is here water. So water, what happens? Heat energy given to the system. So Q should be positive. Heat energy given to the system, Q is positive. So no need to think about the negative value. This you can ignore. Q should be positive among this answer. And then work is done by the system. Why work is done by the system? The liquid water convert into vapor. So liquid water convert into vapor, meaning expansion, volume increasing. Whenever volume, liquid is having less volume if you compare water vapor. So if liquid convert into vapor, there is increase in volume, which is nothing but expansion. So there is work done by the system. Expansion meaning work done by the system. Compression meaning work done on the system. So in such cases, heat given to the system and expansion observed. So work done by the system. So in such cases, W should be negative. W should be negative. And here we know, according to first law of thermodynamics, delta U is equal to Q plus W. Q plus W. So W is negative. Q is positive. W is negative, Q is positive. But Q is maximum magnitude, because more difference in temperature, magnitude is very high. Magnitude is very high here. So that's why what you will get, if it is Q minus W here, magnitude is very high because Q increasing. So Q increasing here because of maximum amount of heat energy or microwave in under 1 minute. So because if magnitude of Q is very high, if you compare the W, then overall resultant delta U value should be positive. This value should be positive. So here key point is whenever Q magnitude is very high, because for 1 minute we are keeping in microwave, so very high temperature you will get. The work done by the system, it is less if we compared with whatever Q here. That's why whatever you get value delta U is equal to positive here. Remember, fourth option. Next, 2025 January shift. See here now. A liquid when kept inside a thermal insulated closed vessel at 25 degrees Celsius was mechanically stirred from the outside. What will be the correct option for the following thermodynamic parameters? Okay, kept thermally insulated closed vessel. So meaning here Q should be 0. Like thermally insulated meaning Q, there is no exchange of heat. Q is equal to 0. Right. So stirred from the outside. What will be the correct option for the following thermodynamic parameters? So how we need to check? Here we know delta U is equal to Q plus W according to first law of thermodynamics. If Q is 0, then delta U should be equal to W. So delta U should be equal to W. So in such cases, whatever value we are showing for delta U should be equal to W. If delta U is greater than 0, W also greater than 0. W also greater than 0. So in such cases, if delta U, Q is 0 first of all, if delta U is greater than 0, W also equal to 0. So easy questions, 2025 as well as 2026 questions, easy questions. But here you need to think about first law of thermodynamics. I hope all the questions clear to everyone. If any doubt in basic terms, please watch previous video and come to this video. For more updates, follow the channel. Thank you. Thank you everyone.